What's up, YouTube? It's your boy, DV. If you didn't know, we just did a reaction. Tej and Melky react to Theo, react to Prime, react to Professor, react to Prime, react, and then there's actually not enough space in the YouTube title to fit the whole thing. So you can go check that out on the main channel. Anyways, advent of code day 5. Let's get moving, shall we? You take the boat and find the gardener right where you told him he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter the water. Sand filters. Nice. Can't make snow with dirty water. Fair enough. Don't worry. Sure, we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that's headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island almanac just arrived and we're having trouble making sense of it. Okay. The almanac, your puzzle input, lists all of the seeds that need to be planted. Okay. All the seeds that need to be planted. It also lists what type of soil to use. Oh, hello, Saloom. With each kind of seed and what type of fertilizer to use with each kind of soil, what type of water to use with each kind, and so on. Okay. Okay. Every type of seed, soil, fertilizer, and soil is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3, and fertilizer 1, 2, 3 aren't necessarily related to each other. Okay, so they're all unique numbers. That's fine. For example, we've got these 4 seeds, and there's different seed to soil map. 50, 98, and 2. Okay, I'm assuming, well, let's go down here. Start by listing the seeds need to be planted. 79, 14. That part's easy. We can do this part. The rest of all that contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. The section starts with seed to soil map, describes how to convert a seed number, the source, to a soil number. Let the governor which so and so on. Rather than list every source number its corresponding destination one by one, the simple way, the map describes entire ranges of numbers that can be converted. Each line within the map contains 3 numbers. The destination start, the destination range start, the source range start, and the range line. 50, 98, and 2. Okay. So consider the seed to soil map. 50, 98, and 2, 52, 50, 48. First line has a destination range of 50, sure, and a source range start of 98, and a range length of 2. That means the source range starts 98 and contains 98 and 99. Okay, so it counts itself. It counts itself, chat. It's not 98 plus 2. Okay, that's already, I already know we're going to scuff it up once. All right, the destination range is the same length, but it starts at 50, and its 2 values are 50 and 51. Yep, this information. You know the seed number 98 corresponds to soil number 50, and the third seed's 99. Okay, so it's like you map this number to this one for this range. Okay. Okay. Yep. The second line means 50. Oops. 50 to 97. Yep, that makes sense because it's 48 of these. Yep. And so each of them goes here. So basically, okay, so you just subtract the difference between these basically, or like you do the difference between them. Happy birthday. How did you know? Oh, Patrick, that is close, dude. We're going to get so many cute little off by 1 errors. Oh, we're ready for it, chat. Any sort of numbers that aren't mapped correspond to the same destination. So seed number 10 corresponds to soil number 10. Okay. Yep. With this, you can look up the soil number card for each seed number. Yep. Dang, how did everyone know it's my birthday? How did they know? Seed number 79. Yeah, this is okay. So I get this. I get it. We're gonna mess it up. We tried to Ocaml with Cody. It was really nice, Pravon. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that maps to any of the initial seeds. Seed to soil? How many of these do we need to go through? Okay, I guess we'll just read this. The lowest location number. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. So seed 79, soil 81, fertilizer 81, water 81, light 74, temperature 78, humidity 78, location 82. Okay, so this is just literally going through each of these and applying the same maps, right? So it's like, okay, so you've got 79. So you go in here and say, 79 is actually then 81. So then you go to 81, you say, okay, it's actually 15. So then it's like 97 or something, or maybe it's subtracted, and then okay, and then you just go through each one, right? 81, yep, then to 14. So then what to say? 81, yep, then to 81 again, then 74, 78. Okay. I'm doing great, Yash. How are you? What was he asked for? Which function to use for different stuff? Nice. In case some people aren't aware, it's not actually my birthday. So it's not actually my birthday. That's later. I'm gonna turn 30, chat. Big news. What's the lowest location number that corresponds to any of the initial seed numbers? I didn't fool you. Someone just randomly said on their first time chat. Stratoblaster said, happy birthday. What am I? Right here. Here. That's exactly what someone whose birthday is would say. Pretty sure you can look mine up. Okay, I'm trying to think. So my first wonder here is there any trick? Is there any trick to this? Like the thing that I would do is I would probably go through each of these and like you could just make a map probably and apply, because like the intermediate ones don't matter. You can just like apply, right? But this one's not, this part is not, there's no, so I'm just trying to think, am I missing something? Like, I don't think that won't take very long. It's literally just going to be like 100 of these, 100 of those, 100 of those, 100 of those, 100 of those. Like, it's just like a few hundred instructions. So this one should be fine. So, okay, so let's just try. Let's just try, chat. Oops. Oh, oops. This is the... Right, so I need to go to inputs. New 05 test. I do want to check just to make sure before we spend too much time. They're like in this order, right? It's seed to soil, and then soil to fertilizer, fertilizer to water. They're still in the same order. Nice. All right. So that part's good. So we've got this going. Oops, there we go. We got to change this to day 5. Wonderful. Maybe one size out. Okay. So we need to parse this first. One thing I was thinking was we should go back. Oh, hey. Thanks, hopefully you can be the happy engineer when you're here. I want to yoink a bunch of these. And I think I want to make I gotta skip. Sorry. Totally. First, you subbed before even chatting. Giga Chad behavior here. Module, let's just say A. Include angstrom, which probably we need to add here as angstrom. And so I want to have is digit white space and W stir. Okay. So we can build up a few utility functions for ourselves. Moomy, it's a parser combinator library. It's going great overtime. What about you? So what we want to do here is we basically want to say, okay, so let's do let parse puzzle lines, I guess, right? Oh, I guess we just want to read this as one big string, don't we? I mean, this is all we want to do, right? We just want to read all. So what are we going to do here? What's the school color scheme? It's my colors. You can find it here. It's a little bit different because I have some stuff changed in my own config and things like that, but why always make functions? Utility. What? Why you always make function? Utility. What? In these codes? What do you mean? All right. So if we're thinking about this, how does this start? It starts with seeds. So we would do like let parse. Let's just let's do parse seeds is equal to, we should be able to do like open advent dot a is string seeds right. We can do this, I think, right? Oh, actually easier is we can go like this. We don't need the strings. Then we want to do set by one white space and digit. Actually, we probably should just have let space take while. This should take some. Take while space core int t list. Nice. Gonna get some lists. Never mind. By the way, I started streaming from last 2 days doing league code. Nice. Congrats. Oh, Johnny. Hey, thanks for the sub. Okay. So this gets us a seeds, and then we should basically expect to get some string, a new line, basically, right? So let's just test this out. So we should be able to let seeds is parse. Parse string, consume prefix, and then I don't remember the ordering here. Right, so it'd be parse seeds and lines in this, and let's return seeds for right now. And let's go ahead and do result dot value. Does it not have? Ah, okay, nice. Okay, sweet. Oh, this doesn't do the right thing. That's fine. We'll just do, yeah, we'll just do this for right now. It's fine. Seeds. This is fine. This is fine. We'll do it like this. So let's do match input with okay seeds, list iter seeds. Is this not? Oh, whoops. Let input is parse puzzle input. Okay, so we failed this one. I don't know if this, should I not have this? Assertion failed. Which plug are you using for the inlay hints? It's just one I wrote myself. Parsing failed string. But it's pretty easy. I think I have it. Whoops. Did I put it here? Handlers? I don't even remember. Oh, this one is code lens, I think, for this, right? Because this is for OCaml. Dang it, did I do it again? Oh my goodness. I literally told myself, don't do this again. You did this last time. Okay, nice. We're good. Okay. Sweet. So we got 14, 79, 14, 55, 13. Great. Then we should have a new line. Right, so now we should basically say chomp this, string, new line, new line. Great. So this is seeds. Well, we can do it like this, right? So this is seeds. And then we're going to say let parse puzzle. This is actually, we want to just say like puzzle is equal to let seeds is parse seeds in seeds. We'll say return seeds like this, right? Int list t. Great. So then this should actually be, let's do puzzle. I'm happy whenever someone mentions them. Only like, oh, we're coding it all in OCaml, my camel. Oh, we're working on advent of code, day 5. So then we should be able to do, we should be able to discard white. We'll just do white space. That's fine. Okay. So then we should now get to seed to soil map. I can just skip this line. Whoops. What did I just do? What? Oh, it got, okay, that's fine. We'll just quit this for a sec. Oh, sorry. One sec. I forgot. I was rewriting a different plugin and I broke it. So 1 second, chat. Hodl. Oh, dang. Unhappy engineer. Thanks. I don't want to dox myself. Okay. Sweet. We should be good. Okay. Nice, we're back. Why black screen? How is to write what, Bravon? I just had to make sure I didn't accidentally dox anything on my other screen. Okay. Day 5. Okay. That's why the right JS. Oh. Anyways, hey, thanks for the subs, Unhappy Engineers. Really kind of you. All right, so then we should have here we should have seed to soil map, which really we can just, like, realistically we can just skip this line. take while. Is there like take until? Take till, right? This should be like read a line, right? Because now we should have numbers. These are like our ranges. We take a like destination, source, and length, right? So like type, what are these? We'll call this like a range map or something like that. And we have destination int, source int, and length int, something like this, right? Something like this. So we should be able to do destination digit. We should have like a white space digit too, right? Let's go to here. We should have like a W match or something like that. I don't know if what you would want to call it, but then you would just do this for W match this. Oh, whoops. T like this, right? So you can say W match digit in this source and length, destination, source, length. Oops, not this. Nice. What? Oh, did my... What? Did something happen with that? Day 5? Okay, cool. What is the star and let? So, what you see here is actually it's kind of like, they're called like custom let bindings. Part 1, don't know what's wrong with my solution. Yeah, Jonathan, I do need to go kind of fast because I do have to get to work at some point, but if we have time after I'm done, we'll go over it. So this basically says, this is kind of like, it's basically like a fancy way of doing, like how you do in Rust, like let X is something, and you can do this, you know what I'm saying? Where you do this sort of try. It's like a monadic line. I'm sorting here, but I followed you back. Well, welcome. So / welcome back. Oops. There we go. Destination 50, source 98, length 2. Is that right? This is Berkeley Mono. There we go. You define your own let with custom pattern matching. I'm not quite familiar with Rust. It's actually part of, so like oftentimes you'll see this let plus be defined by different libraries, and it's basically like a way that you can do like this one is map, and then this one is bind, right? So it's basically like a way to map and bind different items. So this is like, if you got seeds, then we're gonna keep going. I don't want to spend too much time. Oh, cool if custom modern and let defs are shown as an overlay. What do you mean as an overlay? This pattern is super common in a bunch of OCaml libraries. Like this is actually defined by angstrom. So it lets you really easily use angstrom to say like, I'm going to take this thing, and if that matches, then we're going to do this thing. And then if we're matches, it's going to shown as an overlay. Oh, on the stream. Oh, like how they do for games. Oh, that would be cool. Yeah. So then it's like, okay, if this one matches, then we're going to do this. And then if this matches, right? And then at the end, we're going to return this, right? So it's really like, it makes it super nice. So then we have seed to soil. So each of these really, if you think about it, are the same thing, aren't they? Because we have basically like a, we need to keep doing this section here, right? This is like, and then we're going to yoink all of this. Let x equal 1, and the map will be like what matches to what's the let equal, right? Map will be like what? I'm not sure exactly what you're saying. With stick UI does shorthands with some Unicode symbols, shows what they are vertically scrolling on a small space window at the right as an overlay. Interesting. Next, if you've got an example, yeah, that'd be interesting. Be fun to build one in OCaml. Hook it up, do something crazy. Okay. So this gives us a parse range map, but the problem is we actually need to parse like a bunch of these. We need to get this one, and then we need to get the next one as well, right? So we want to keep doing this until we get to an empty line. Musa, what's up, buddy? Yeah, that'd be cool. So we want to actually keep on, we want to get a list of these. So these are, like this is parse range map. What we actually want to do, let parse ranges, is sep by 1 string new line, right? Because it's going to end here and here. And then it's going to be parse range map. Now the problem is I'm thinking this won't actually work. Because this yoinks up too much. We should just do digit for this to not consume that, right? Oh, they're only separated by 1, right? So there should just be 2 for this one. Okay, nice. So then we need to do so this now pulls, you know what we could also do, which would be nice, is if we go back to Advent here, we could do okay. So now we get a new line, and we need to do the same thing. Is there a TJ Discord? There is. Okay, let me just think about how, so I would do this. We get a white space, we get all of these, right? So this is basically let parse, or we're going to do, okay, so now we have the ranges for one map. We're actually going to need to make a map of maps. We need to make, or a list of maps, right? And we're going to basically do this whole thing here. Maybe we should give it a name as well. Trying to think if it's helpful just for debugging, but I don't think it's gonna be. So I think we're just gonna do. You do this, right? You get this digit, and then oops, I want to do this way. I want to discard that. Okay. So now parse ranges, we should be able to do. Oh no, we can maybe do this. Let's see. This should really be parse map, and we yoink this into here, and then we can do that. And then we want to do set by 1, parse map. We want to do string. I think 2 new lines should hopefully do it, right? And then this should now be nice. Okay, cool. Let's check and make sure we parsed all these correctly, because I think this should work well, though. There's winning no fun. Why Western? Config in Lua is cool, and it also was doing it was doing a cool it was just rendering some fonts better. Cool. Confirmed, not spam. Okay, I'll check that out after we're done. Thanks, Nix. Been a Java dev for 4 years, and this is like watching magic. Okay, so everyone see what we're doing though so far. We've got the 0, 1. Here we got 1. I don't think it matters, so we're not going to keep track of which thing is which, right? So we have 50, 98, 2, 0, 15, 37. Okay, so that part's all good. So here's what I'm thinking. It was mainly the font thing is the reason I switched. I'm thinking we can fold this over. So I was trying to think of this. Like, so basically you just need an array, or like actually maybe it's easier with a map. And I was thinking I should look at our actual like input one though, right? That's the wrong days. So these are kind of big numbers, right? 100, 1,000, million, billion. Okay. It doesn't work as good for big numbers the way I was thinking originally. Because what I wanted to do was I basically wanted to just like reduce all of these. But I don't think I want to make a billion long. Like I could have a billion items in here, right? Hundreds, thousands, millions, hundreds, thousands, 100 million. Yeah. Okay, so that way it doesn't actually work very well for the real solution. I don't think. We'd be doing a lot of iterating and storing stuff in memory. Okay. Okay. What if we turned each of these into a function? Because there's like, let's say 1, 2, 3, 4, 5, 6, like 10, 20, 30, 34, maybe like 40 of these or something. I don't know if this is going to work for part 2. Everyone's saying part 2 is crazy, so I have no idea if this is going to be a terrible solve for part 2. But I was thinking we could turn basically each of these into a function, and you're going to find the first one where it matches, and then you're going to return the new number, and then you basically go over to the next one. So basically, like, what am I saying? You have this number, right? So you take this number and you go to seed to soil, right? And you're looking You're looking at this and you're going to say, okay, is this plus this greater than this? No. Okay, go to the next one. Is this plus this going to the next one? Is this, and then once you find one, you say, okay, cool. And then we go to the next map. That's kind of what I'm thinking. And that should work okay for part 1. And part 2, we're going to get there. So, okay. Let's just try this. Let's just try this out, right? I'm going to change this to be T. Whoops. We're going to do module. Let's just put a little module in here because it'll be easier. We don't need to do that. Let's do, okay. So we've got this. This part's all good. Great. Part 2 made me regret doing this on a Raspberry Pi. That's funny. Okay, yep, don't do any spoilers though, chat. Don't do any spoilers, right? Okay, so we have this is our map. These are our maps, right? Here. And so I'm kind of thinking, what are we going to do? We're going to go to here. And we want to try and do something like this. What's our end result supposed to be? Let's just try and do the very first one, right? So the very first one. Oh, right. We're looking for the min. Nice. Spoiler, Snape kills Dumbledore. Dang, dude. I was going to read that. Are you kidding? Are you kidding me, Oscar? Okay, so what do we want? Let's first just see if we can get this 82. I don't know if spoilers will help. Yeah, but they could still, right? All right, so let's get seed is list head seeds in this. So we get our first seed, right? And then what are we going to do? We're going to try and map this seed. So the way I was thinking of doing this is we can fold over the maps, right? We have some initial value, which is, I don't know. How do I pick a really big number for this? Or we could just do none. Is there like math infinity? Int.infinity max value. Okay, nice. There we go. Didn't know where we could find that one. Function ac and m. And we can just do this, and we can say let's folded. I don't know, we'll just say that for now. All right, so it's just a big number right now. What, are we doing suffering yet? No, not yet. We're taking our time. We're chatting. We're having a good time with using Angstrom for this too, so I think that part's good. That's awesome, Spoof. Nice. Okay, so what do we want to do here? We basically want to do list find from the maps. We want to say a particular m. We could say range. What do we want to say? If range dot destination or source less than or equal to seed and range dot source plus range dot length is greater than or equal to seed, then sum map, else none. Let, we'll call this range. Is this? Oh, we can just say, oh, sweet. Okay, that's even nicer. So now we have some range, right? So then we want to do let map, or let, you know, yeah, we'll say maps or something like that, right? Would be range. This is seed. So how do you do this again? This is like, this one is, the first one is 50 to 98, right? And it's range 2. So you had 79. So these are two different. So it's this number minus this, or this number minus this number plus your original, right? So this one's destination and this one's source. So we do like seed plus range dot source minus range dot destination. I don't know if I did that right or not. Right, and then we need to do match range with sum range. We're gonna do this. Ac plus, oh no. We'll just say this. None ac. Just so you can see something like destination before source. Yeah, I know that it's destination before source. I have that already. I already stored them as destination, source, and length. I was trying to figure out which one I need to add and subtract. I probably did this backwards, but that's fine. So then we need to pick, we need to do something like, this one doesn't end at 75, does it? Oh, no, because then it's going to be seed. It's supposed to end at 82. Okay. Yep, they're all on VODs right there. Same, who would put destination first? Guess it's my bad for not reading correctly. Yeah, okay, so let me just hodl chat. So if we have a range, this is for each map, right? So for each map, what are we gonna, no, this should be ac. But that's the number that we put in. Oh, this should be, we need to pick min of ac and this. No. This is just dumb. I think I'm just being stupid. Because this should be for seed. I think I was getting ahead of myself with fold. I think I'm getting ahead of myself with fold. So let me slow down. Bad cop, great idea. Great idea. As well, by the way, we do have, or not, I have this one. We've got me and the milkman reacting to Theo, reacting to Prime, reacting to Professor, reacting to Prime, reacting. We did it. It's live. It's here. The chaos is nowhere, like this is the chaos that is this video. Okay? Okay. Okay. Now this is art. That is art. This is not what we want to do here. By the way, this is not what we want to do. What do we want to fold over? We want to take this. This should be seed. And then this is actually seed. And then this should be like this. This is actually way easier to think about, right? So, okay. So this probably is backwards. So we should print along the way what we're getting. So we start with 79, and that should go to 81, but we went the wrong way. So like I said, minus this, plus this. Exactly like what we said. So it should go to 79, then it should go to 81, 81, and then it should go to 74. Yep, and then 78, 78, and then it should go to 82. I'm gonna subscribe on Twitch. Tachi, nice. That's funny. That's funny and smart. My subs are the smartest. Tefir, hey, thanks for the sub as well. 18 months is forever. Yeah, you usually never up. Let's go, bad. Let's go, bad cop. Okay, sweet. So that's perfect. This is exactly what we want to see, right? So this, basically, these are all the intermediate steps here, right? This is basically like, so we should do something here where we can make this a function so it's not so confusing. This is basically like map seed. And this should take some seed and maps, right? And this takes some int and some range list here, right? And does this, right? So then we can say map seed with a seed and maps. And then we can say this, right? So this is the first one. So now we want to do list fold. Now is when we're going to do this. So we're going to say seeds, and we're going to say init is int.max value, and f is going to be function ack and seed, right? What are we going to do? We're going to go let mapped seed, or we'll say location is map seed and maps in this, right? And this should be an integer now. Nice. And then we'll just do min of ack and location. And so then 35, and the answer is 35. Nice. Nice. Okay. Should we do it on prod? Should we do it on prod? I guess we just do it live. Why OCaml? Why not Haskell? Great question. All right, prediction time to bet, chat. Here's your chance. Okay, here's your chance. Bet now. Do day 6 with Haskell. No. I will do no days with Haskell. If there's something wrong with parsing, we won't call it as first try because I haven't tried to parse this one at all, but I'm pretty sure it should be the same. Okay, just to be clear. Okay, it was pretty fast. With these odds, you'd be a fool to go yes. Movie Jumala in shambles. In absolute shambles. Choose outcome, yes. Complete prediction. Chat, we're writing OCaml. We're writing OCaml, okay? You're not thinking clearly. You're not thinking clearly, okay? I mean, they won like nothing. Yeah, but you lost everything. What did it cost you? Everything. What did it cost you, meme? How does this go again? This isn't the right one, right? What did it cost? Me getting an... This can't be right. Okay, it doesn't work. I was trying to think like doubters voting no, but it doesn't work. Okay. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like seeds line actually describes ranges of seed numbers. The value on the initial seed lines comes in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. Okay. Was expensive highlight. Dang, it feels good to be a gangster. Well, we don't have anything else to do with the points, right? Bad cop right now. Maybe we'll add something. Maybe we'll add something. So in the first line, these are 2 ranges of seed numbers to be planted in the garden. The first range starts with the seed number 79 and contains 14 values. 79, 80, 90. Okay, nice. The second range starts with seed number 55 and contains 13. Okay, yep. Now, rather than considering 4 seed numbers, you need to consider a total of 27. Yeah, and in this one, we need to consider a lot. We have to consider a lot of numbers. Like a lot of them. Now we go from casual 10 seeds to a few billion. Yeah, just a lot of them. I think we need to consider at least 2 numbers. I'm considering, so here's what we should probably do first, chat. You brute force is like 2 billion. Should we just run one in the background and see which one finishes first? Me, brute force, versus me. We could also run them in pair. Well, dang, we should just do this as an opportunity to try OCaml multi-core. Right? Like, we should... Oh, brute will be faster. I know, because it's only going to take a few minutes, probably, right? So it's not like... Okay, let's do the brute force one first, and we'll start it. We'll start it in a new one. We could probably pretty easily OCaml 5 EIO. My brute force took 40 minutes to run. Well, what language did you write it in? Because was it in a crap language? Yeah, okay, TypeScript. Well, okay. I don't know what to tell you. There's like parallel 4. Was there like try, or it's like for loop or parallel? I thought there was. Okay, well, let's just try it on a single core. We won't even cheat. If yours takes more than 12 seconds, bash greater than OCaml. Oh, no. Wait, Bad Cop, did you do a brute force in bash and it still worked? Ooh. But did you do it in... Were you using GNU? Oh, domains lib? Maybe I was thinking of domains lib. Because all I need is a parallel for loop, basically, right? I just need a pool, and then I just need to run some function. But it's okay. I didn't do brute force, so it would have taken centuries. Okay, nice. All right, let's hodl. Good solution takes a few milliseconds. Okay, let's do it the bad way first, right? So now we have seeds. So this is going to be part 2 brute force, right? And we'll yoink all this stuff here, right? We'll take parse. Trying to think how would I do this really easily. I guess I shouldn't spend too much time thinking about how I'm gonna write this, because I want to just do this. I just want to do this. I want to do this quickly, right? So it's like, so we have seeds, which should be some int list, right? So then we want to say like let new seeds. Am I really just going to turn this into a bunch of huge lists? Yeah, we're going to do that. Split the ranges into groups of X width and get each CPU. Right, that's what I was thinking, but I'm not going to do that. After optimization took less than 1 millisecond. Yeah. So we're going to do the really slow way first. And then we're going to do start and range. Get seeds. Rest. So now this should be a list of int. Oh, seeds like this, right? Okay, so now we should be able to do... It's whatever. We'll just start with this. List range. Start. Count. Start. Start plus count. List. Fold. Init is ACK. F is function ACK. Seed. Whoops. Is this even right? This doesn't even seem right at all. Dune exec this. Oh, and then what we should do, let's just print starting new seed range. Start count. Let's just make sure that we're actually starting something here. I don't want this to be in watch mode though. We just want to do this. It would be pretty sad. All right, let's just see if that goes on here. Try it on test for a quick test. Oh, that's probably a pretty smart idea. Oh, but I just started this. All right, let's instead of prod here, let's go to test. So then what should this get us? Should it get 46? Number's 46. Nice. Okay. Yeah, this is the bad brute force. Okay, nice. So we'll just leave this running. This one's just running, okay? We'll just leave this one running. And then we need to yoink all of this, paste this here, and then we'll comment this out because we're not going to actually run the brute force. Real force. Okay, so now we actually have to think. It'll tell me. It'll tell me. If it's a long time, it'll just tell me. It looks like it's going to be slow. What I probably should have done is instead of serial, like actually making these lists, which this is not good really. Because this is basically like, this is going to make a list of all these numbers and then fold over it. I'm making so many allocations right now. Like, this is so bad. This is like the worst way that you could possibly do this. You know what I'm saying, chat? This is just bad, but that's okay. There is probably, but I don't remember. Don't tell me they're linked list. Oh, baby, they're linked lists. Heck yeah. We probably could just switch this to arrays and it'd still be fat, and it would be faster. Well, really, we don't even need to serialize this. Like, this doesn't even need to be like, your cache is crying. Oh, it's crying. What? Yeah. So, okay, there's got to be some way. I actually have been wondering about this anyway, so we can ask ChatGPT anyways about this. Is there how to get a sequence from X to Y in OCaml, not as a list, but as a seek? Because we have these. Because I need this anyways. I've wanted this a few times, so we should use this anyways, right? Oh, that's cool. Let's see if this works. Has type int in option, but expression type int. Did you forget to provide? I think it's just this, right? Yeah. Close! You almost had it, ChatGPT, it looks like. So let's try this. Let's do advent dot range start plus count, and then sequence dot fold. Isn't there no really? There's really no sequence dot fold. Fold left. Nice. Okay, so for some reason this one doesn't have. Is this not bases or cores? I guess not. Core doesn't have one. Okay. Oh, nice. Yeah, we're almost done. Okay, but we should check and see how much faster it is to just do this way instead, though. Right? This expression is type int. No, this literally does list range. What the? Oh, range seek. That's what we wanted anyways. Oh, right. Dune exec day 5. Oh, we probably should have tested this to make sure. Prod. This still gets me 45, right? Oh. Okay, that's a problem. Is this inclusive? Oh, 46 is right? Oh, I thought it was 45. Oh, nice. Woo! Okay, cool. We're still getting 46 then. Oh. Oh. Oh, Chet, did you just hear that garbage collection? Oh my goodness. Ah! Uh-oh. Chrome's having trouble, chat. You can hear it. You can hear it going right now. Your mic died? My mic shouldn't be dying. My music is going to be dying, though. Wow. I think I'm just literally running out of memory, probably on the computer, right? Because these... Oh my goodness. It's actually dying so hard. That's hilarious. Here, I'm going to turn the music off because it's too disconcerting. Yeah, I know you can hear me. Oh! Wait, it just crashed. Ah! It just crashed. We just out of memoried and then crashed. That's hilarious. Okay, that's pretty funny. To be fair, we did literally the dumbest way possible the first time. So let's go ahead and try this again. This time without making the lists every time. Range sequence. Yeah, this should be good. Dang it, now we're gonna have spent more time trying to make sure that this one works than it would have taken to do the real one. Okay. This should hopefully go significantly better. I mean, not making a linked list of all of these guys, of 300 million items, probably should be better. Okay. All right. So that should be running. So now we need to think, chat. Now we need to think. And I need to make sure that I don't have a meeting right now. Okay, nice. We have a meeting. We don't have a... Oh, nice. I don't have a meeting. Nice. I bet it could handle 3 billion. Yeah, the problem is I think I was not... I don't know. I'm surprised that it crashed like that, but I don't know if it was because I was running other Dune stuff at the same time and trying to do other things. Oh, for me? What up, buddy? Hey, you ready for... How you feeling for NeilVim Conf? All right, so confident. Nice. So let me think about this a little bit, chat. So this is now a range of items. I'm guessing like they don't overlap a lot, but I mean, I guess it would be worth checking. Like this one, 999 million. Does this overlap any other ones? Or this is billion? Yeah. Okay, so that's... I don't think overlaps is going to save us at all. I have to think about what actually it would take to get to a good one. This is going pretty all right, though. This is going pretty all right. I still feel like there should be some way for me... We definitely don't need to check all of them. Like, that's definitely stupid. Like, a way that you could not check all of them would be you sort of like... You could evaluate like ranges of them. I still don't know if that's a big enough win. So like I'm thinking, okay, you know what I'm saying? You get this number and you're going to add this number to it. So you're looking for like the first number that's like less than this. Ooh, what if we sorted all of these by their start number? It's actually not a plugin. It's in help list and help list chars. Okay, so my first thought of how we could do this much better, I don't know how we would write this super nicely in OCaml. I would sort all of these maps by their starting number. Then what we're going to do is we're going to keep moving through the maps until we find the first one that is less than the number that we're starting with, basically. So something along those lines. And then we're going to take all the remaining ones from here till the end of the list. And we're just going to like, we can map all of those easily. We run those through the rest of the things, right? And then you go with the one above it. Looping 0, finding the first location as a matching seed instead of trying each seed. What about looping from 0 and finding the first location that has a matching seed instead of trying each seed? 2 runner first skipping every 1,000 in the range, saving the window seed. And the offset for the winning range, run it again for a limited range, since result will be close. Is that true? Because if it's not in the map, it's maps from IDX to IDX. Right. So then we would just like, we would map the rest of those remaining. Because you could like split it into more sub ranges. Oh, we're cruising now though, chat. Assuming that we didn't scuff this somehow, we're cruising now. The thing you're describing, but starting at the bottom. Oh, so you ordered them the other way, bad cop? You're saying? How many seed combos I have? 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. I have 10. Start from the last match, and we're back to the seeds. Fold is kind of like reduce, yeah. I don't think I can talk about my approach without spoiling the solution. That's fine, spoof. That way seems kind of like still pretty complicated, but still like I definitely don't have to test every number then, so that's good. What if we think about this a little bit better? You don't have to do any of... Oh, but you could have to do some of the middle numbers, right? Because I was thinking you could... So... Okay. Also free processing, not actually checking seeds. Yep, that makes sense, spoof. So, okay, so what if we start at this one? We only need to care about... I'm trying to think, like, is there anything we can do inside of here where we go backwards and we only keep track of the minimum one? Because all we're looking for is the smallest one, right? So you're saying, like, okay, from here to here, the minimum is going to be this number. And from here to here, the minimum is going to be this number, right? So like, let's say you take these ranges. Let's actually go to the simple solution because it's a lot easier to think about. Okay, nice. We're on 5. Very cool. Previous range should throw to 0, which means having a result smaller than the smallest range. No. So I'm saying like, okay, so you're right here, right? So you could break this into, you could map this into something like, okay, so 56. So I'm trying to think. So basically you could say this is the source and this is the destination. This adds to it, right? So I'm trying to say like temperature could throw you to lower than lowest humidity to location. Right, but you could take a range of numbers. So you start with 0 to infinity or something like this, right? Actually, what I'd have is basically like some conditions. I'm trying to say you could find several spots where you know the smallest numbers are. Right, because this takes 56 and maps it to 60, right? And 57 and maps it to 61 until 93 or whatever and maps it to 97, right? So you know that like 55 is going to be, so I don't know. I'm trying to think if there's a way that you could sort of say, you could turn these into conditions where you can tell if a number is smaller than another number, but maybe that's still not good. 1, 2, 3, 4, 5. Breakpoints with source and length. Right. Just finish my solution. No brute force. Nice. Nice. I don't know if we have enough time to write this solution, but I'm just trying to think it out. So, because basically what you want to do is you want to map all of the numbers, right? You want to take all the numbers and you want to map to which one's going to be the smallest, right? And you can discard all of the ones that you know for sure are not going to be that. Being able to have a number smaller than another. Not sure if we have that technology. I think we've lost. But do you need to start at 0 since the sample solution is already below 56? Yes. So then you basically have to find a way to this is the part that I'm trying to figure out. Like, how would I express this in code? Because then basically you're saying everything 0. Oh, okay. Let's think. You want to break things into like ranges. So this would be like 0 to 54. 55 or to 55. 56 to 93. These are all this is like a separate category of numbers, right? So you can say like this one is 0, this one is 1. 56 to 93. So this is 93 maps it down to 56. Something like this, right? Then you have like, or this would be like this. 93. Right. So I'm trying to figure out, well, how could I express this, right? You have to consider what the ones above it map to as well. Right, I know, Destiny. So I'm saying you could get, I'm trying to figure out, can I make a range from this to find out what the smallest number would be? And then you basically think about it as like a series of transforms. So this one tells me which numbers are which numbers would be the smallest. Then you like apply it to this one. And then you would apply it to this one, and then you would apply it to this one, and then you would apply it to this one, and then you would apply it to this one, and then you would apply it to this one, and then you'd apply it to this one, and then you could think about it on the range here. Right? And you'd be able to say which of these is in the range with the smallest values. What about the ones that are not found in any of the ranges? So you would have a range that covers all the values. The key is in the map that turns the key. You always have to start from 0. How easy do you think AOC is using Python? Well, if you want to do brute force solutions, probably not good. Like me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are we on the last one? I think we're on the last one. If we get the right answer, we'll be done. I don't have enough time today to do everything. Hopefully we don't randomly crash again. That would be sad. I'm going to be extra sad if it doesn't work, too. Yeah, I think Python is a pretty good one to solve this in. Or to solve AOC in. Like, I think it's fun. So I'm saying I get the right answer. Can we spoil faster ways to do it, though? If you get the right yeah. If I get the right answer, then we'll talk about which ways are good. All right. That was 10 minutes. 11 minutes. Oh, here we go. Let's go. Nice. We did it. We could have made this way faster. We could have made this way faster if we did each of these in parallel, right? But then my computer might have exploded. Well, that's cool, though. I still think it's cool, right? Like, it's still cool to solve. That we can just reuse the same idea. All right, chat. Give me your good solutions. I don't want to think about it anymore. I have to go to work. I'm already late. I don't want to see other people's solutions. That's cheating. But we'll look at this one because it's in Rust. But we'll look at this one first because it's in Python. Normally we stop the video and make a different video at this point for YouTube, but since we didn't do a good solution, then we'll get it this way. Oh, nice. Programmer solution. We got to check out the bash solution, of course. Okay. So parse the files, that part's fine. Map to locations. Depth, tabs, nodes, start source, end source, location. If node.name is location. What is this even doing now? Okay. 8 space tabs. Big number. No, I know. I'm just trying to figure out what is this code even doing. This reads the file. Nodes. It gets all the nodes. T seeds. Gets the seeds. This is just part 2. Okay. Start seed. And then to the last seed. For the length of the seeds divided by 2. Nice. Okay. Yep, so this gets your seeds. Great. Otherwise, it gets the from and to. Oh, I see. Okay. All right. Return start source and lowest val. 4 start. Oh, okay. All right. So this is actually like, this actually looks like you're going to do, it's like, it's a search problem. Took like 10 seconds and the elixir might have just gotten lucky with a low number as the answer. It's turning the input seeds into range, start, range, end. Right. So that's pretty cool, right? This is basically like a search problem and you're searching for the lowest value all the time. And you're going to pop them back on, or you're going to push them onto your list if end source is less than source or start source is less than start. Right, so you're like, okay, sure. Start offset, end offset. Destination start, destination end. Lowest val is lowest val or map to location, which is this, right? Depth plus 1. If start source is less than source, then we're going to do this. If end source is greater than these, then we're going to do that, right? So this is basically changing these into the distinct, the ranges that we were talking about, right? And then we're going to do 4 start source, end source, and source ranges. We're going to take the lowest val and get the min of all of these and do this, right? So basically this, oh, sweet. So this is really similar to the idea I was, oh no, this is similar to the first idea that I was talking about, right? Where you're able to go from the beginning of each range and you break. So you don't go backwards and like map them. You're still going forwards here, right? Who sent this one? You're still going forwards in the search. Right, through the maps. You didn't try and do anything backwards to basically like pre-calculate them. But you are basically getting to the end of where each of the ranges are, and then you're going to split them and then search at just the edges of those ranges. Very cool. Python +1 for this one. Output range, the output range of location is infinite. Yeah, okay. All right. Let's see this Rust one. Source length. Run inner seeds map part 1, solve part 2. Part 2 is the only one we care about, right? So get the ranges. Yep, that's good. Sort unstable like heat. Nice. This is what I was saying. Start by sorting them for the map in maps for map for new. So we've got let mute new, some new vector. Okay. So seed range in seed ranges. Mute done false. Okay, interesting. So we're mutating the seed range. Also Rust 70. Nice. So then we're just going to turn these all into ranges and see if it contains this range. We're going to turn this into a range contains this. If our map range contains the seed range and it contains the end, then done is true. Oh, cool. Okay, so this range completely encapsulates a seed. That's this case. Right? If map source... Why does this have 2 dots? How can that work? Oh, this is the range. I thought it was accessing, but right, it's just the range thing. Map range source to map range plus map range length contains seed start. Okay, so this is where it's overlapping sort of at the beginning, but not the end. Right? Otherwise, if seed range contains... Oh, if the seed range is bigger than the range. Otherwise, this. Okay. If not done... Then push seed range to owned. New push. Seed ranges is new. Seed ranges equals new. Interesting. Okay. So we're going to keep doing that each loop. So we're going to have some possible seeds, seed ranges each time. Didn't want to think, just use threads. It's nice. Min by key r.start unwrap.start. Very cool. Okay. So let me just... We're not going to break this down too much, okay? But basically, in this case, what you're going to do is you're going to handle the different ways that these can overlap each other, right? The ranges, whether you're going to have a completely overlapping range with the seed and the map, whether it's inside, whether it breaks, or whether it's like the seed completely contains it, right? And in each of those cases, you're going to push a list of new ranges that you need to deal with. Okay, right? So you're kind of like iterating through all the seed ranges. And then eventually, right, you're going to go through all the different maps. Oh, okay. So this one's interesting because it does it for each map. So the maps don't change. That makes sense. And you're basically going to say, here's all the ranges of seeds that we possibly have. Is the sort in the beginning necessary since you need to check all the ranges? Oh, that's an interesting question. I don't know that it is for the inputs. Dude, this is really cool. This is very nice. Very nice. Okay, so we were on the right track with what we were talking about doing, right? Am I crazy in thinking that we were at least on the right track? All right, here's the madman. Okay. Range intersection. Okay. If this one's greater than this and less than this, then we're going to return otherwise. So you're doing, this is literally the same solve. Is it not, bad cop? Oh, it's not the same solve. Oh, I missed it. Do the thing. Right. Okay. I was just thinking here I was seeing a bunch of the same sort of stuff at least. Absolute mad lad here. Range and seed. Okay, so this is for each range for each seed. Read range. I think I'm too tired. I don't think I'm going to understand this one, Beck. There's too much going on in this one. You got some real magic. I mean, good for you, obviously. But too much magic. This is 6 or 7 head at least. They make it a little too easy. True. All right. Ruby. PowerShell when? Part 2. So get all the seeds. Sections map. New seeds. Okay, nice. So people are doing basically the same. This is very similar idea as well, right? A, C, D, B. Yep. Contained. Completely contained. Broken. Broken the other way. Broken the other way, right? No overlap. So then you just put the next seeds and then you keep going. Seeds plus equals new seeds. Go back to the top. Do this again. Oh, dang, some coding guy. Hey, some coding guy. I was wondering, could I get a license? I've been struggling to do this, some of these without the regex, and I thought maybe I could get a license. Could you just put me, just me? Could I be the only one? I was just wondering. Oh, sorry, Cody guy. I thought you fixed it already. I was just wondering, some of these problems are sometimes a little hard for the, you know, without the regex. So I was wondering if I could get one. Yes, yes. Although I did use parser combinators instead, and they are nicer. So I'll still be okay without one. So it's like you still, so it's a little hard, but occasionally I did. What day was it? Was it day 3 that I think I would have made Prime really mad, or was it day? No, it was day 2. It was day 2. I used the regex unlicensed. Sorry. Prime spent so long parsing these, and you can just literally look at the line, and just say how many reds do I have? How many greens do I have? How many blues do I have? You didn't even have to parse them into hands or anything. Like, you didn't have to do anything. This is all you had to do. Right? No regex, exactly. So this one was good. This one was really funny, and Prime was really mad on stream, so I was like, yeah. A day 2 uses regex change each line due to a math expression. Nice. Okay. Anyways, if I can get on here, I'll be very happy, but all right. So this is a really good strategy though. Why is there Pearl in OCaml? It's the regex. My eyes. I'll cite you. Let's go. 0 regex for my day 2. Sweet. That's all I need. I don't want it after this. I don't even want to have the temptation. You know what I'm saying? Like, I don't even want the temptation. It's not that I think I can't handle it. It's that I don't want to deal with it. Okay, so this is actually maybe my favorite solve so far. Good job, Ruby. Because I think that it's super obvious what's happening. I can't believe it. My favorite solve so far is Ruby. But this is really nice. Full overlap in the comments too. It makes it perfectly obvious what's going on here. It's the only tool when parsing HTML. This one gets a very big +1. It's nice. Oh, nice. The output for the Python one. Yeah, this looks great. This is very helpful to see what ranges you're checking to check your work, to make sure everything makes sense. This is really cool. And you have to check so many fewer than the billions that I checked. But the funny thing is we got this, we both got the right answer, so that's okay. Oh, nice. Here we go. Here's Bash Cop's explanation of the bash code. So there you go, chat. I mean, simple, really. It's just simple. Spoof? I don't think so. I'm coming at this one, right? I'm coming back to it. I just saw this picture and needed to make sure that we went over it. It's so clear. It's so clear now. It's so clear. It's so clear. No, I was before that. This one, right? Wait, did it? Which one? Spoof, send it again. I might have just not clicked on it. It's not this one? Oh, no, it's not this one. All right. I'm gonna check Spoops. All right. Dest source length. Take length U size. Length minus this. Oh, that's cool. Nice. Seeds, seed to soil. Yep, so each of the different maps. That's cool. Map ranges.partition point. Oh, cool. Same energy. Yeah, I was gonna say. I knew what the image was already. Nightshade. Offset seed minus source range. If offset's less than the range at length, range dest plus offset seed. Returns and map end. So there's m.map seed is equal self map seed RHS map seed. This works similar to the merge step of merge, where we sort the range of RHS by their destination start, the range of LHS by their source start. Then we iterate through both lists, merging the ranges as we go. Oh, very cool. So here's your iterator that you're walking through as you go, right? We'll take one look at Perl and then we gotta go after we look at these two Rust ones. Well, this is less than the left-hand range and this is less than the right-hand lane. We're gonna keep on going up. We're gonna get the values. If LHS range dot length is 0, I plus 1 continue, which will then quit it out of the loop, right? This will quit it out of the loop as well. Oh, this is okay. This is the range of these. Okay, I see. Source less than dest. Length is the destination source minus the okay, right hand range. Min with this. Okay. Outranges, push, map range. Okay, so you're just gonna make a bunch of new ranges that you need to do, right? Yep, nice. So then you're putting all the new ranges in. And then handle the other cases. Yep. And then you sort them all by their source. And then now you get map ranges is out ranges. Nice. Okay, so then you're going to compose all the maps, right? Because where are you using this compose? Nice. Yep. Okay, sweet. So this is kind of similar to this thing I was saying at the end, right, Spoof? Because you go backwards. Humidity, location, temp to this, temp to... Right? This is pretty similar to the idea I was saying at the end. Where I was saying we can walk backwards from the end and find each of the ranges and put them inside. And then we basically have one final map that takes some range of items and maps it to their final value. Basically, right? Like we just have ranges and offsets and then we map them. So you can just walk them through once, right? Just like the picture. That's very cool, though. All right. Let's see part 2. Bar chunks 2, flat map. Yep. Proxy all. Maps iter fold seed value map proxy 1. Is this just brute force? This is just the brute force one in Rust, right? Null addict? Or no? Nice. Very cool. Oh my goodness. Wait, I'm getting written up. I thought I was getting written a license. Wait a second. I thought I thought I was getting a license, not written up as a citation. Oh no. Oh no. Oh, that's not what I was expecting. Oh, man. F's in the chat. I'm on the short list. I thought I was... Oh, I thought I was getting saved, but I've actually been being written up. It's like when... It's like if your parents tell you, we want you to tell us when you did something wrong, and then you tell them that you did something wrong, and then they ground you twice as hard. That's what just happened. I thought I was going to get some leniency for confessing. You know, I confessed to the crime. Double the sentence. Oh, no. I thought I was so safe, chat. Thought I was so safe. You're going to use less plugin and use built-in features? Sure, where it makes sense. But I have a ton of plugins. We're so it's so over. It's so over. Okay. Someone sent me a Perl one. We'll look at it. They're definitely getting written up. There's no way they did this and they're not getting written up. They're definitely getting written up, okay? They're Oh boy. Oh boy. There's like more regexes than regular statements. There's like more 100% regex. It's just only regex solved. Sure, I'll look at it real quick and then I gotta be done. I gotta go to work. While it's a map is chunks.pop. Okay, nice. So this is are these your ranges? Oh boy. I can't understand what's happening in time. Is this part 1 or part 2? It looks like part 1, right? Most readable Rust functions. I think I prefer the bash solution. I'm turning into a true... Okay. Oh, it's both. Nice. No, okay. So I'm pretty sure this is a similar idea to some of the other ones, right? Bash and OKM aren't so different, you know? True. If you think about it, you call bash functions without parentheses. This also ran in sub MS though, so it's fast enough. Definitely fast enough. Mine ran in 11 minutes. That was fast enough for me. Because it worked. Bash pipes are just OCaml pipes. Yep, you call functions without parentheses. You just need the correct answer. Mine was 4 minutes. I need to keep tweaking it. My day 3 OM's at 1 minute 30. Uh-oh, Nightshade. Uh-oh, Spaghetti-O. All right. I don't think I can... This is good, it seems to me. Seems like you're handling some of the same cases here where you're checking, okay, is this one within this range? Probably could make a range out of them and make sure that it's contained or something. This one is also pretty similar, where then you're going to push the new range and some new value that you're going to check, and then temp push, then you do the curve values, and then you just keep going. Like, which I like this. I like this. This strategy, we should definitely be thinking. We should definitely be thinking as we go forward, because I wasn't thinking about it today, about like search style problems and how we do that. It'll take me a little bit to remember how to write those well in OCaml my camel. But it's sweet. My brute force runs in 20 seconds and 1200% utilization. Nice. Nice. Okay. Sorry if I missed your code. I gotta go. Say goodbye to YouTube. Bye, YouTube. We'll be back. We'll be back later. See you later. Okay. Tell him, chat. Tell him goodbye. No one wants to say goodbye. Okay, fine. Okay, nice. Fine. Now you guys are saying goodbye. Okay. There we go. Sweet.